Live to the world. All right, now I'm going to hit the actual go live. We're only live on YouTube here. We keep it simple. You know, when I go to a dance, I just dance with the girl that I brought. I don't dance with everybody.
Well, you're missing out.
Yeah, I know. That's yeah, I go one way or the other, you know. Mono or poly, you got to pick one. So, okay, now we're live. We're still pre-show. I'm going to put out the tweet that at least lets the folks know, and I'm going to let our channel know here so we can get some chat going. Hello out there. If you're already watching, welcome. Feross here, Patrick there. ReScript is the topic for today. And throw out a tweet. So, while I do this, I'll give you the rundown, Patrick. So, it's roughly 45 minutes to an hour is like the produced time. This might take slightly longer. We edit down a little bit. We'll edit for smoothness. We don't do heavy content edits, so it's going to feel like a conversation. That being said, if you want to start a sentence over, or you screw up and you're like, let me try a second chance at that, you really, biff something, no big deal. We're happy to edit those things. The live show is just probably like, 2 orders of magnitude less than it'll actually go out to. So no pressure on the live show. It's just our closest friends here. So if you want to start over, totally cool. Just be like, let me try that again. And then just stop, give us an easy edit stop, and then pick back up from where it goes. There'll be a couple of breaks during the show. Those are for the there's edit stops, but it is a good chance to go to the bathroom or get a drink, or sometimes we'll back channel between segments. Leave your recording going the whole time. We're also still going to be live the whole time, so you're not like totally private at that point, but you are like off the air in terms of the produced version. That's the gist of it. We have an outline. We have some top thoughts and stuff, but we do like it to be like, feel like, we're at a party and we're discussing ReScript, and you're the pro and Feross and I are the noobs, and that's kind of just the way the show goes. Cool. Any questions for us?
For us or for us?
For us.
No, I'm fine.
Okay. Everybody can start their locals. If you haven't yet. If you already had it going, that's all good. Just let it roll.
Test. Yep.
Thomas is in the chat. What's up, Thomas? He thought he was going to be on the podcast. Oh, because you guys share a last name. Oh, no. One letter off. Eckert versus Ecker. So, sorry, Thomas. You missed the podcast by one letter today. What else? Haven't tweeted yet. This is a lot like walking and chewing gum. Only slightly harder. Feross, have you used ReScript? Have you used ReasonML? Have you used OCaml? Have you used anything that's not JavaScript?
I'm kind of vanilla, honestly. I'm not even sold on TypeScript, so I'm like really vanilla.
Yeah.
But I did get on the CoffeeScript train back when that was
Me too.
Yeah, and I got kind of well, I guess we could save this for the show, but I got kind of burned by that.
Once bitten, twice shy.
Yeah.
All right, real quick, just for easy editing, we're going to do a clapper. I'm going to say 3, 2, 1, and we're all going to clap into our microphones, and I'll use that for syncing in post. Ready? 3, 2, 1. All right. Now we can go. I almost started the go time song because I did that yesterday. Here we go. Can you guys hear my soundboard? Hello, everyone out there in JavaScript land. It's your internet friend, Jerod, and I'm here for a fun show about ReScript today. Feross is joining us. What's up, Feross?
How's it going, Jerod?
It's going good. Hey, you launched a new thing. It's called Wormhole. How's that going? Good?
Yeah, going pretty good. Yeah, it's fun times.
Tell the folks what it is real quick.
Yeah, it's a tool for sending files to people with end-to-end encryption. So you can safely send your files across the interwebs.
Yes. It's like Firefox Send, only they shut that down, and this is probably even cooler because you built it. Maybe you have to give us the skinny sometime, like when we did the nitty gritty on BitMidi. We might need to regroup and get one for Wormhole.
Yeah, let's do it.
Awesome. Sounds like a plan. We're also joined by Patrick Ecker, who is with the ReScript Association. We're here to talk about ReScript. You may have heard of ReScript, maybe not. Maybe you heard of BuckleScript, maybe not. Maybe you heard of Reason, maybe not. Maybe you heard of OCaml. Maybe you've heard of none of these things. We're going to sort through all that and hopefully dive deep into this cool language and ecosystem for building web apps. So, and maybe even more. Who knows? Patrick, welcome to JS Party.
Thank you for having me.
We're excited. I thought we would start with all of that because I had never heard of ReScript, but I had heard of Reason, and I hadn't heard of BuckleScript until I read the rebranding post. But y'all have been around for a while in different forms, and there's like multiple tools that have come together to kind of unify and hopefully have a cohesive story going forward. But give us the background, these disparate tools or involved tools, and then kind of the coming together. Maybe sort through that from the start, and then we'll get into the nitty gritty from there.
Sure. Yeah, this is probably the most famous question whenever is someone asking about ReScript, because a lot of people got in touch with ReasonML and BuckleScript, which is like a cohesive tool chain. Like Reason is the syntax and BuckleScript is the compiler, which takes Reason syntax and then which looks also a lot like JavaScript and compiles to JavaScript. And this has been going on for a few years. And they also made some like cross compilation story out of it. And then people got involved with a lot of OCaml, which this whole thing is built on basically. And we never thought that like this cross, like there was like two communities going on. There was one community going more into this native exploration direction. They wanted to compile to native. They wanted to have a nice garbage collected language that is almost as fast as Rust. And then we had like the JavaScript story, which should be like a single tool chain. It should be simple to understand. It should be easy to integrate in existing JavaScript code bases. And this was also like the bigger like setting point of the platform, because a lot of people got into this JavaScript compilation thing, and they used it actually in their projects for more than 2 years, 3 years in production now. And we wanted to, like the major problem here was that people got confused. So they got into the community and they were like, okay, I want to do ReasonML. What can I do? And then they're like, oh, do you want to do native or do you want to do JavaScript? And then it's like, okay, what do I do? What is like the easiest? And it's like, oh, you can do this and that with this compiler or with this compiler, or you can do the OCaml array with something else, which was always confusing. And we never liked the idea of decoupling like the syntax from the compiler. And in 2020, we after 1 year of development of an like a rewrite of the syntax, we decided to align the compiler with the syntax, with this new syntax, which is actually even more JavaScripty as ReasonML, and called it ReScript. And we also made it really, really clear that this is all about JavaScript development. So we built a tool chain which kind of feels similar from a workflow perspective. So you basically install like similar, like other compile to JS languages like TypeScript or Elm or whatever. You install one npm package, npm install ReScript, and you've got all the tools you need to compile ReScript files to equivalent JavaScript files. And ever since we did that, suddenly people get it. People get to the platform, they get to one cohesive website, all the resources are on there. We have a cohesive story for React development. We have cohesive stories for how to integrate it with Next, how to integrate it with like any React application that already exists. And we made it really clear. We also removed all the wording for ReasonML or OCaml because it's not relevant anymore. We care about like minimalistic design, minimalistic CLI, no configuration or low configuration actually, and also a formatter, like a syntax formatter without any options, like without any of them, not even like the width, not even semicolons, nothing. There's just one style basically enforced, and we are really, really glad we did that. Like, we are really happy that this is now now it's easy to understand, and now we are happy, and now we want to start out again with a fresh brand and a cohesive story.
I just have to say, the more you kept talking, the more excited I was getting. All the words you were using: minimalist, no configuration, formatter without any options, no semicolons, like focusing the website down. I'm really curious now to try it.
Right. It's so exciting also for me, because I'm also not the biggest fan of like this bulky, huge languages that give you like 15 different configurations, and every project looks different. And and the second thing is, like, the major selling point of the platform is that it's fast, like ridiculously fast. It's hard to describe actually. We try to build a platform that doesn't rely on caching. So we can compile, I don't know, 3,000 files in a project once, and then can start a cold build, or actually we do a build, we cache files on the file system level, but we don't need like an extensive incremental background service, which requires like 2 gigabytes of RAM, like in TypeScript. If you want to have a fast build, you need to wind up this huge server, and then it indexes all your files, and then caches get invalid in between in memory. And then you switch branches, and then suddenly all your type information is kind of corrupted. And then you need to do a cold build again, and this takes 20 minutes. Like if you have a big code base, like a serious code base. For smaller projects, probably not a problem. But ReScript really scales with like the amount of files you have. Like if you start out with a 10 files project, it's it's instant. It's less than like it's 20 to 50 milliseconds per build. Doesn't matter if it's like an incremental build or a cold build. And then you have like huge size projects. Like I have one client who has like 3,290 files or something. Like the first initial build, if you like completely clean this whole thing and build it once, it takes like 1 minute and 30 seconds. And this is not even optimized. There are like a few things you can tweak to make the compilation faster. But after that, like you change a file, and it doesn't take like forever to just recompile this one file. And it doesn't really rely on these caches I was talking about. And then things get way less complex if you can just rely on one simple command that winds up when you need it and then winds down when it's done.
Oh yeah, I mean, so zooming out a little bit, it sounds like you got really good performance on builds, and it's as far as a compiled language goes, you have a lot of nice features. But like, why would I use ReScript over just plain JavaScript? Because plain JavaScript files have no build time. So why would I? What am I getting by using ReScript over plain JS or something like TypeScript?
Yeah. So plain JS is a dynamic untyped language. So for me personally, when I write a bigger JavaScript application, it's usually very hard to maintain it or refactor it, especially if it's like a really complex code base with a lot of people working on the same code base. If it's like a React application or an Angular application, doesn't matter. TypeScript tries to mitigate that by adding, like, being a superset of JavaScript, so you can turn around a JavaScript file into a TypeScript file and it will still compile, but then you can also add type annotations and stuff. So it is a gradual type system. And these ones have the downside that they need to deal with the complexities of JavaScript, because JavaScript is a very dynamic language. It is very polymorphic. You can do a lot of things you usually cannot do in like statically compiled sound languages. And what ReScript is, it's a sound typed language. That means that every value in your program needs to have a type, like has a type annotated. There is no any type, there is no mixed type or no unknown type or some sorts of that. which makes it very robust. We also don't have, like in the language, in the core language, if you just write ReScript code, you don't have any null pointer exceptions because we don't have any null. We don't have the concepts of null. And instead have a few other niceties which help you build very complex applications. For instance, we've got variant types, which are also very well known in languages like Rust, which is a data structure to design complex domains. It's kind of, if you think about like TypeScript, when you're using a tagged union, you usually have like an object type, and then you have an attribute type on there, and you call that type user, and then you have some certain attributes available because this is like a user type, and which is kind of like abusing the object type of some sense, and then gradually like refining the type. In ReScript, we have the variants, which look a little bit like, I don't know how to explain it. You would define a type user, and then you have constructors, values. You call that, I don't know, admin or user or privileged user or moderator. And then you can attach data to it. So you can say, you can have like an admin constructor, and this one contains like a string for the username. And then you can just use that as a value in your program. And then you can pattern match on that with a very powerful switch like state like expression. So you can really like design your domain just with types, and then later on use these values to manage your application code. And the sound type thing is also very nice because like refactoring is a totally different story there. Whenever you're doing TypeScript, you're installing some libraries. These libraries maybe involve some definition files. These definition files may come from a third party that is maintained independently from any other, like from the actual library. Maybe it's like an add-on, which is maybe the library is not written in TypeScript and you write a definition file for that. So information can be stale or wrong or some sorts. And it's not always clear when you refactor a code base or when you raise a dependency or when you do this kind of stuff, if your code really works. And as soon as you have like this one trust issue in your type system, the type system suddenly isn't that nice anymore. I mean, you have autocompletion, yeah, and some other nice tooling opportunities, but the full trust where you say, okay, when the program compiles, it will like work unless I'm doing like, you know, bailout functionality for communicating with external JavaScript. Yeah, that's really great if you can do that. If you can say with a convincing voice, okay, yeah, this program compiles, I'm pretty sure this would just work.
So no bugs. That's what I want. I want no bugs.
And I mean, you will still have bugs, right? But
all right, I'm out.
it's very easy to at least say, if I change the interface of something, the compiler will really help me. Like the compiler error messages are really good, especially with this variant types I was talking about. When you change something and then the compiler will say, okay, this interface doesn't match here and there. If you do pattern matching and you're, for instance, adding new cases to a variant, for instance, I have my admin and my moderator and I want to add a user variant constructor or whatever, then pattern matchers, wherever I have a switch expression, the compiler will tell me, hey, you forgot to add the user constructor case. And when I remove the user constructor, and it says, there is no user constructor. So this is super useful when, for instance, you're building React components. And, you know, like React components in the beginning are super easy. You're like, oh, I need to have a button. Okay, HTML button, that's it. And then it's like, oh, but we need accessibility, right? And then you need like, okay, I need to annotate different states when there's an hover state or when there is like a click hover or when you're like a touch, when you have touch and other interactions. Suddenly the code gets really, really complex. And when you look at things like Tailwind did a really, really great like library for doing the heavy lifting for you, where you get React components and then you just use them and they implement the complex logic in the background. Maybe check that out. Check out how complex this code can get with TypeScript. Just because they're using these tagged union objects and then they try to shoehorn it in with some switch statements, and then it's really hard to read, and then you need to annotate everything because the type system needs more help inferring all your types. In ReScript, every type that is inferred from the compiler is 100% correct. And this is also very, very nice if you can trust the compiler there to do the right thing.
Mm-hmm. Well, pattern matching is really cool. So that's a great language feature that I always appreciate. It's difficult sometimes, I think, when we are, hearing about something brand new, like unfamiliar, to like get a frame of reference. ReScript is it's its own language, right? It's a language that compiles to JavaScript. And so what are some hooks that people can have, not like specific features, but like, is it like anything else? Like, is it kind of like Elm? Is it kind of like ClojureScript? Is it kind of like, and we've already contrasted it from TypeScript. It's not a superset of JavaScript. It's not JavaScript. But
yeah,
would you say there's like, it's Elm-esque in terms of it's a language kind of FP style? Go ahead, answer that question.
Yeah. So no, it's actually not. It looks a lot like JavaScript, acts a lot like JavaScript, and in our opinion, compiles to the highest quality of clean, readable, and performant JavaScript, which is really nice. It's our marketing pitch. So our idea, like this, which is kind of rare. We haven't seen this before. That's why we build it. You really write your code like you have your typical let bindings or let variable kind of thing. We call it let bindings. So you define a variable or you define a function with arrow function syntax. We only have one syntax for functions, which is the arrow syntax, which compiles to an actual named function. So you don't have to worry, should I use a named function or should I use a named function without a name? Should I use a arrow function? Should I use or should I use bind or whatever? We don't have that concept. We just use the arrow function syntax for that. We don't have classes, which means that we replicate the behavior of classes by saying that we just think about values and functions, and then we have a pipe operator to chain all these things together. So we can model an object-oriented system just with values and the pipe operator, which looks a little bit like PHP because our pipe operator is basically like an arrow, so a dash angle bracket.
Mm-hmm.
And which means, I cannot interact with object-oriented systems like with classes in existing JavaScript code, right? But we can, because we also added to this, we added an external syntax, it is called, which is defining, you can define an external that binds to an existing JavaScript function. And you can tell the external binding if it's like a new constructor, if it's like a class constructor, whatever, or if it's like a method function, you want to call this, where you put in a value and then it calls the function on this value, like with a method, right? And so we can interact with like the more complex features of JavaScript, but in the core language, we don't need that. And when we look at a ReScript file, so we have a ReScript file, which is .res, and you compile it with the compiler, it will create an equivalent JavaScript file right next to it. And by default, when you define a value or a function inside a ReScript module, this value will automatically be exported or exposed as an export in this generated JavaScript file. And our recommendation is to write your functions and values just the way you're used to in ReScript. You can do for loops, you can do while loops, you can do like your typical array map and whatever. We have all the bindings there for all the JavaScript web API collections and arrays and whatever. And then you open a new tab with the JavaScript output, and you can see that the compiled output looks very, very similar to the actual ReScript code, if done correctly. So this allows, and since this idea of one ReScript file is one JavaScript file. You can integrate it really, really easily in existing code bases. So if you decide on, okay, I just want to have one React component written in ReScript, we have like dedicated, first of all, we have JSX syntax integrated in a language. So there is like, this is a one-to-one equivalent thing. You can just use JSX in the language without Babel and whatever. The compiler will compile it into equivalent react.createElement calls, or in the new JSX API, what's out there now. And then you just have this, one React component, put it into JavaScript, like compile it to a JavaScript, and then import it from other React components as if it would be a JavaScript component. And this partial integration is one of our most interesting features, because people can first try it out and see if it fits their use cases. A lot of people are having, like, they cannot just rewrite the whole code base. Nobody can do that. And with us, it's like, okay, if you want to just try out one part of your application, and maybe it's a very complicated part, and you're like, maybe this brings us some value because we have like very complex interactions, or maybe I'm building, I don't know, a code editor, a rich text editor, something with a lot of state and a lot of state transitions. Maybe let's try this with one React component that is written in ReScript, and then let's see if it works. And if it doesn't work, if you do it correctly, and you have always like the JavaScript file on the side to see the output, if you do it correctly, you can even, like, after some time when you decide this is not yours, you can just remove the ReScript files, check in the JavaScript source files, maybe rewrite it a little bit to make it a little bit cleaner, and you're done. You don't lose much on productivity there. And you're also not forced to rewrite it again in your specific other language you want to use, or JavaScript. So yeah, this is just the insurance from our side that you're not locked into the system if you don't like it. Does this answer the question? I'm not sure. Sometimes I'm talking and then I'm like, ooh, getting into all these details. But I hope you know what I mean.
Yeah. Okay, we'll take a break right here. You can sit back, relax, and get a drink of water, something like this. Yeah, I was playing around on the playground as you were talking, and I'll probably bring this back up on the show, but it is remarkably similar, the output to the input, at least in the default case you have that loads in the playground.
Yeah.
Yeah. Which was surprising.
Yeah, it's unique.
Yeah.
It's really a unique selling point here.
Does anybody need to step away for a bio break, or have anything to say that they want to not to be on the show, or but it's about the show, or you want to tell a dad joke or anything? We prefer to save all dad jokes for on air, but sometimes you're not sure how bad they are. All right. Well, we can hop right back in. Maybe we'll just pick up with the playground and kind of getting started, you know. It seems like that's a good place to pick up with new eyes. All right, here we go. So let's say I'm like Feross and I'm excited. I'm like, hey, ReScript, let's give this thing a shot. I know nothing about it. I write React-based web apps, and I'm at least interested enough to hop in and see what it's all about. What do you tell folks? Where do they start? What should they avoid, etc.?
Yeah, so the most important thing is we have everything on our website, rescriptlang.org. We've made it, we hopefully structured the documentation in a way that it's easy to follow. We usually recommend to start out with the manual, which is more written in a narrative style. So you start at the introduction and you go through the installation, and then you can dive through the most basic features. We didn't mention the more advanced features yet on the manual, because we thought it would be easier for most users to just use the most basic stuff, and you can build all kinds of React apps with that. And after you get some idea of the language, it is very, very important, because a lot of people are coming from a JavaScript background. They want to interact with existing JavaScript libraries. And we've got a section there for interoperability for the external bindings I was talking about. So you need to get familiarized with how do I bind to an ES6 module? How do I bind to like a value to a function that is exported from a CommonJS module, maybe the default export, or how do I design, how do I map to a JavaScript class there? This is probably like the first thing you should definitely check out and at least try, because a lot of people have this urge to jump into the ecosystem and like look for ReScript bindings to existing ReScript bindings that bind to some JavaScript library. But this takes away a lot of learning possibilities. If you're in control of writing your own bindings externals, it's much easier to do stuff, like generally speaking. And as soon as you got this, we also got a ReScript React documentation section, which covers actually all the basic concepts of React. We tried our best to also cover all the React topics, because oftentimes we just refer, like some people refer users to the original resource. So go to reactjs.org, learn React, and then come back to our resource and learn ReScript React. We don't do that. So you can go from topic to topic there. How do I use GSX? How do I create elements? How do I mix them up with existing components? And how do I export it to JavaScript so I can use it in JavaScript? So from there on, it is usually recommended to just drop into your React code base, run npm install ReScript in your dev dependencies, and set up a config file with npx ReScript in it, and just point to the folder with your components, and then create your first ReScript file, write your first component, try it out, and wire it up in your existing JavaScript app, and that's it. Then you can, from there on, you can just play around with all the features and see if you like it.
So it seems like kind of like Swift in that way, where, you know, when Apple was trying to encourage everybody to switch over to Swift, they had these large Objective-C code bases, and you could just sprinkle Swift in file by file, or maybe even class by class. In this case, maybe component by component. You're like, well, I'm going to write this component in ReScript, and it's going to generate this nice looking output that I get. Do you check that into source code as well? Or I guess
that's a really good point. Yeah, we actually recommend checking in the JavaScript output files.
Really?
For the reason, because first of all, if you're like trying to bring new technology into your company, you need to convince your coworkers as well. And if they see, like, it's a matter of politics as well. So you check in the source code, they can review ReScript code in their pull request, and they can also see the equivalent JavaScript code. And second of all, it's also very useful to spot regressions if you're doing some bindings and then you mess up a binding and then suddenly the output changes. You see that as well, which is super useful. But people will see the output and they're like, oh, I can understand that. This is not that scary. And since ReScript is so fast, like the compilation itself, it will also not have a heavy toll on your CI workflows or like on the consistency for your coworkers. If you check in the JavaScript source code, it's already in there, so they don't need to even run the ReScript compiler first. So a lot of this has a lot of advantages, just bringing in the technology and make your coworkers like you afterwards.
Yeah. Now, what happens when they start editing the JavaScript output, not realizing what that .res file is? And they're just like, I changed this file, and then you just recompiled right on top of my changes. I guess that's the magic of version control, is you can always just go back in your Git history and dig that thing out.
Yeah. And we also generate version headers, so it's usually a warning on top that this is generated. But this is actually also a good point. Like if you're like on vacation and then someone needs to do a hotfix because something happened, they can still, like, even if they don't know ReScript, they can still hot fix the JavaScript source until you're back, and then you just fix the ReScript code.
I think that's smart, because honestly, something like this is like a very hard adoption because it's just so out there. It's new. we're going to talk about people using it and the association and the fact that it's not all that new, but like nobody ever got fired for continuing to use React and JavaScript. But maybe for pulling ReScript in, if they didn't have these paths for incremental adoption, which is component by component or file by file, and then B, actually having both versions right there, and the ability for people who don't want to touch ReScript but have to hop in and fix a variable assignment or whatever the bug is, I feel like it really does make it less risky. And at the end of the day, if your team is like, we're never going to use this ReScript thing, stop writing ReScript, you have the JavaScript files right there. You just get rid of the ReScript files, and it's just some well-formatted JS that you just didn't write by hand. So I think that's a pretty cool thing for adoption.
Right. And I think one thing I didn't even mention yet, because a lot of people like to do like immutable JS or like this immutable data structure story. And I kind of liked it in the beginning too, but then I realized that immutable data structures come with a cost. And in ReScript, we have a concept of zero cost interop, which means that we take a concept and translate it to idiomatic JavaScript without any runtime overhead. And one of that is we have record types. We have record types that compile to plain JavaScript objects. So they look like JavaScript objects, but they behave like immutable data structures. And the compiler will do the work for like doing object spreads or I don't know, doing the destructuring thing. How should I explain this actually? So the optimizations for the immutable data structure so that it's immutable is done during the compilation process and not during runtime. That's probably what I want to say. And this is also really great. We also have like runtime specific data structures built into the standard library. For instance, immutable lists, which are also sometimes very useful. Those are compiled to also JavaScript objects, but with a HT and a TL attribute. Very easy to check out on the playground, actually. If you try to use that, you will see straight away the output on the right side. Yeah, but we also have immutable data structures if you need it, and some of them are zero cost and default. And yeah, this is also really great to explain to someone why this might be useful, because you cannot run into this like weird issues where you try to use the object spread and you think you're immutable in JavaScript, and then suddenly you do some change in an object and you mutate it, and then you get side effects. And this is super annoying.
I'm still trying to wrap my brain around zero cost immutable data structures. Maybe can you explain how that? I mean, maybe not. I don't know. How does it do it at build time? Go ahead, Feross.
Does that just mean that it's like a plain object at runtime, but you enforce the immutability in the compiler? Is that basically what you're saying?
Mm-hmm.
Okay.
So you have to stay in ReScript land to keep that immutable.
Exactly.
Gotcha. Okay, that makes more sense.
So in practice, if I was using ReScript, sorry, this is kind of totally a random question, but I'm just thinking of like what I would actually, experience as someone who's like decided to introduce this into my project. Like, am I gonna struggle to like when I want to use a dependency that I just found on npm? Like, what's the process? What's the actual process like for most packages that I would find in an npm search for bringing that into ReScript? Like, is it a lot of work to write the bindings and all that stuff? And doesn't it have the same problem as TypeScript, where the definition files will get out of date or out of sync over time?
Yeah, very good. You ask really, really good questions. Actually, the best questions.
I'm gonna let Feross ask all the questions from here on out.
Yeah, I mean, this is exactly what we are trying to figure out for the community as well. Like, how this is actually a philosophical problem. How do you make sure that all these npm dependencies or these ReScript bindings to these libraries are always up to date? And my current approach, like my practical approach, is you don't try to write these bindings like for the general community. Sounds a little bit weird. What I mean is, For instance, if I'm trying to write bindings for the full JavaScript web API, when you think about how complex this thing is, like the web API itself, it has like nodes, and nodes are super polymorphic, and it can have like a list of attributes, and these attributes don't necessarily need to exist in certain values, and in certain situations they do. And in a static type system like ReScript, which is also very, very simple, like the type system is not as clever, or not trying to be as clever as TypeScript, where in TypeScript you can have like an integer and an object and a string being in one type. This is not really possible in ReScript. You need to think a little bit more simply. So you cannot really bind to an API, to a JavaScript function that accepts a string or an object or a number or whatever. So you need to make decisions. So you can write a binding that binds to this function, but it only accepts one version of it. So it only accepts an object. And then you name this function, I don't know, parse date with object, or with, like you give it a name that tells the user that this is like the parameter. And then you have another one with integer or something. So there's a lot of opinions going into how do I write these bindings. And that's why I recommend to learn the external syntax and just you define it like a variable, basically. It's like one line of code. You're like, oh, I want to map to the event DOM handler type, or like one method of it. I just create one binding with this particular interface and then use it. And later on, you can extract them into modules and then just reuse them very, very easily. And so you can either share them, you can even like, I usually actually copy paste them around in some projects. If you're like really, really cautious about that and you want to share it in your different code bases and you want to make sure that it's always up to sync, you can of course extract it into an npm package. But many of us actually don't have that many ReScript code bases, and it's actually easier if you have it inline and then you can edit it as you need, and then later on publish it independently from that. But this is more like this vendoring problem, right? So you can have like n dependencies on npm, and those have another n dependencies, and then you're like, okay, how do I fix this one bug, which should be easy to fix, but then I need to go to 5 different maintainers to fix that. So my recommendation would be write them ad hocly, and if you got a collection of useful like bindings that have like practical proof, then it's a good point to start sharing them with the community, because some people start it and then they get overwhelmed with how complex it is, and then they stop it, and then some people rely on that, and that is a problem. So we try to educate the people to really think about what they want to depend on and if they need to depend on it. Yeah.
Probably call this. Do you have a follow-up or no?
I'm
Ross?
good.
All right, we'll break right here then. We're hitting up against the time, but if we want to stay on topic, I thought, why not?
So now is the third segment about the ReScript Association?
Well, I think we could talk about, I want to hear like, community stuff, kind of who's using it. I'm not sure exactly who their like perfect user is, or like who is ReScript's, like, I don't know, I don't want to say like the persona of their customer, kind of an idea, kind of like who's this for exactly. But then like the community, the association, kind of building around it, sounds like it seems like a pretty serious effort at this point, not like a fly by night. I built my own compile.js kind of a thing. So I think making that clear is probably in your guys' interest as well, Patrick. Is that fair to say? Yeah. Okay. Let's dive into that. So Patrick, if you were to meet some developers and interview them, and at the end of these interviews, you could pick one to be like, this is the person that's ReScript is for. This is like our perfect user today. What is that person like? Are they senior level? Are they experimental? Are they building production apps? Are they a large team, small team? Like, kind of give us an idea of who you think who should be adopting ReScript right now?
So what we think our target group is like, our ideal developer is a product person, someone who wants to build nice looking and performant products, and someone who is not too like pickery about like paradigms or like dogmas we often have in the community, also in JavaScript or in Java or wherever. It shouldn't be like a black-white thing. So people are not saying, oh, I only want to do functional programming and I only want to do object-oriented programming. But they are more like, I want to build this, I don't know, crypto wallet with these particular design, and are excited about it and get their stuff done in a timely manner as well.
Good answer. So if you're that person out there, actually for Ross, you're kind of that person, aren't you? Like you're a product person. You like to build stuff fast and high quality and kind of in small teams. And you also work somewhat autonomously a lot. I think a lot of the difficulty is large teams. Like, how do I introduce ReScript? That's why the incremental aspect is cool, because it's hard to sell that to like your boss when it's going out on a limb for what, for benefits, but how obvious and clear are those benefits? But you're in a kind of a position, and myself as well, where we can kind of make the calls on the technology choices and build cool products quickly and with high precision and high reliability. It sounds like, what are the big wins for somebody like Feross? I know we've kind of touched on them, but if you could say like, well, I mean, 0 bugs was was nice. If it compiles, I mean, no tests. Don't worry about tests. It's kind of like the TypeScript promise of as long as the types make sense, but there's no any type. So you actually have to have types. All of my TypeScript types are just any types because I'm just a dynamic kind of a guy. But what would Feross win? Like if he just picked up ReScript for his next startup or his next side project, what would he feel? What would he appreciate?
I kind of feel like, because I've seen a few projects already that are out there, and I can also mention some companies later on. What I've seen is that there are quite a few startups using it, and for them it's actually really, really good, because I didn't even mention that too much, but as I said, like the type inference in ReScript is really good. So people can write their code without much fuss. They don't need to annotate every single thing. They can just write down the code, try things out. If they don't like it, delete the code again. But it's not like the compiler always complaining about certain things. So they can move really, really quickly. And later on, like when they start growing, they don't have too much they have legacy code, right? But they have a much easier time upgrading, because the platform is not as like moving as fast as, for instance, the JavaScript platform. JavaScript can be really, really churning when you think about it. The community is smaller but more focused. We have a very nice forum where you get nice support also by the core team members. It's very, very easy to upgrade code bases later on and stay up to date. And you also can grow, because there is always, like, as I said, the compilation times scale linearly. So you don't have to worry about later on like doing this journey work of, okay, I need to implement some caching. I need to put this into a separate package so I can compile it independently. And then the other one, no, you just put everything in a mono repo, just compile it once and put it on CI, build it once, everything works just the way it worked, like with 10 files. And now with 1,000 files, it doesn't matter anymore. So growing is much easier with that one. And yeah, this is probably my major observation. But also bigger companies profit from that, because like feature teams, for instance, can choose the technology, and if they need to integrate an existing JavaScript code base, they can do that as well. So all use cases are kind of covered here.
I was kind of joking about the whole testing thing, but is there a testing story, or is there tooling around testing, or do you just say don't worry about unit tests because we got you covered?
Yeah, of course, testing is important. We tend to test business logic. So
because that would sell me, wouldn't that sell you Feross? It's like, actually tests, I know they're they have their value, but with our tool, with our language, actually, yeah, just go ahead and forget about them. You're not going to need them.
Yeah.
Well,
I mean,
there is that kind of, there's the certain kind of testing that, you always have to worry about with a normal untyped like JavaScript app, which
Yeah.
is like, do the two parts even connect together correctly? Like, did I rename the function in one place and I didn't rename it in another
Yeah.
place? And there's no way to know until you run the app in production. So you need to have some kind of like integration tests. And it sounds like with this, you wouldn't have that problem with any kind
Right.
of sound type system. You would be able to just ditch those tests.
Yeah. So
Yeah, anytime you're asking, like, did this other part of my program send the right thing I'm expecting, it fixes that problem. But like you said, any typed language does that. What I would love to do is not write any tests. Wouldn't that be the ultimate productivity? Is like, just write the code and it's going to work.
that would be the golden dream, right?
Yeah. So I mean, that would get me on ReScript right away. I'd be done with every other language. I'd be like, all right, no tests, no bugs ever. Boom. But
yeah, no, we definitely need testing, and we usually we're currently tinkering with a very, very, very simplistic recommendation for testing, because right now you can use tape or you can use chest or whatever, but we are not too fond of it because it adds another layer of complexity again. So when you add chest, suddenly you have a lot of configuration again you don't want to necessarily worry about. So what we are currently tinkering with is like a minimalistic test framework with air quotes here, which is like 100 lines of file, like 100 lines file of ReScript code, and you drop it in your project, and then you can just use that test framework with a standard set of like test functionality you usually expect, and just run it with Node. Just run a Node script, and you can run every test individually, like with tape, for instance. I really like this idea of reducing complexity on the tooling side, and we try our best to always follow this philosophy. So hopefully the testing story will be as clean as the rest of the tool chain.
Well, there's lots of stuff here, and it's worth pointing out, it's not Patrick just working on this on your night and weekends. This is a long time effort by lots of people. As we mentioned at the top, like, different projects kind of came together, different people came together and created a ReScript out of these kind of other things that were all working together. The core team is 7 folks, which is a pretty big core team. So there's lots of people working on it. Tell us about the community. I know there's also the ReScript Association, which is kind of like a foundation or like a entity that is building this thing. So flesh out the community story, so that people who are thinking about giving it a shot know what all is there. It's not somebody's side project toy language that they wanted to, learn how to do a compiler. And so they built ReScript, and it's not like that. It's a serious business.
Yeah. So the original project started out in Bloomberg, where Hongbo Zhang, the author of the compiler, started this whole effort. I think this was 5 years ago already. So he started working on this until Facebook came out with ReasonML and got the idea, and Cheng Lu got this really nice idea of making these two things work together, like the Reason project and the BuckleScript project back then. So Facebook and Bloomberg kind of collaborated on this thing until it grew a few years and the community started to shape around it. We had a few startups in there. We had a few bigger players in there. For instance, we had Sotheby's, which is a bidding platform for expensive artwork, which is located in Iceland, I think. And we have companies like DraftBid, like a startup which has like an online editor for creating mobile apps, like a no-code tool with a lot of interactions and a lot of complex workflows. They're really, really happy with that. Of course, in Facebook, they have been using it in Facebook Messenger app, like on the web version. and which is also fully written in ReScript. One of our team, core team members is Ricky Vedder, who is also working on the Messenger team. So we've got like the insights from that as well. We have companies like Ahrefs using it. They are a huge player in the SEO sector for analyzing SEO data. There is Ubisoft Club, or Ubisoft Connect now. I think they rebranded. They use parts of ReScript in their React Native app. And there's also some interesting companies like in Japan, Elm Inc. They built like an app which is called Fast AD, or Fast ED. It's like a smartphone platform for the field triage of stroke patients. So when you think about like these medics or paramedics currently in the field, and someone has a stroke and they have like a response app where they can ask for help and ask for symptoms. This was very important that the app doesn't crash. And for these use cases, like where things should not crash, no matter how tricky it is, like ReScript is really good. So these companies adopted it. Or CCAIO, which created an app for mission critical railway safety. So when there's like a train passing down, like in Swiss or in France, passing down a red light, they have like a huge form where they stop the train and then you need to fill out this form. And this is a very, very complex logic behind it. If you make a mistake, you can get in troubles because there's like a train standing on the tracks, and if another train goes by, then you have, you know what I mean.
You don't want the form. You want that form to work, is what you're saying.
Yeah, sure. And and companies like TinyMCE, they are building like a rich text editor platform with ReScript, and for that is also like fantastic. Like this really complex domains. This is where ReScript shines. And on the team we've got, as I said, Hongbo Zhang, who is now also working for Facebook, Cristiano Calcagno, who is like one of the cleverest scientists I know. He has been working on the Infer project, if you know that, for code analysis and static analysis of all kinds of languages. So he has like huge knowledge about analyzing code, which is great for us because we have a lot of dead code elimination analysis going on right now for ReScript because it's like fully typed. It's super nice to analyze. We've got Cheng Lu, who has like a huge vision on products and designs and lean, clean interfaces. I love that as well. Maxime Walke, who is like our master brain on the syntax level. So he has been investing so much time into writing a parser that is efficient and small. Like a syntax parser, super fantastic work. And and myself, of course, for working on the documentation. And I've been doing this like inside within the ReScript Association, as you already mentioned. The ReScript Association was founded with the goal to support the community and support support the language with financial infrastructure so people can send donations to it who are relying on the technology. So if you're a company who wants the language to succeed, the best way to invest money is to invest it in the association. They're allocating the money for developing the documentation, growing the editor tooling, working on core essential libraries, funding other projects, organizing conferences. We had like 2 conferences already, ReasonConf 2018 and 19, and also a Reason conference in the US, which will most likely, of course, be rebranded to ReScriptConf. So in the past 2.5 years, we also collaborated with some research institutes and companies. Like we collaborated with Ahrefs, which I already mentioned, with Tezos, with the Tezos cryptocurrency. They are also really invested in this because they want their crypto wallet apps to be stable. And they chose ReScript for their web frontends and stuff like that, or subsidiaries of Tezos, of course. Tezos is a huge project. So this is like how we try to set a foundation for the language on the community side, on the open source side, but also we have a strong commitment on the business side with the core team who is working at Facebook and all other companies that depend on it.
Mm-hmm. How about you personally? How are you paying the bills?
I'm currently I'm getting funded, of course, with the work at ReScript Association, but I'm also doing contracting right now. But I'm actually gonna start working together with another company who is using ReScript, which is Rohia. They're building a sales enabling platform, and I'm really, really excited about this.
Cool.
Building something neat.
Building cool stuff is always fun. How did you come to the project? We didn't cover your personal journey to ReScript. What got you excited? What got you into it?
I don't know. I started out in flow type. Basically, I was like trying to contribute to the flow typed project, which is kind of the equivalent of definitely typed for flow, and try to get involved with this work. And this excited me. And flow was a really, really nice project with the type inference and such, but TypeScript kind of won this war, I would say, or the marketing, and I kind of felt disappointed because I didn't like the idea of TypeScript at all, like the performance metrics and stuff like this. And in 2017, I got introduced to Reason, and I got really hyped up with the idea of having this like polyglot platform of like having one language, but it compiles to different things, and maybe you can have like alternative syntaxes mixing together, but which was the initial pitch I got in my head. But later on, I got more involved in this and started meetup groups, one in Vienna and one in Munich. And I also organized the first Reason conference in Vienna, 2018. And this kind of grew on me. And I was like, okay, there's one thing that's missing, terribly missing in the Reason community, that is a unified documentation platform. Because every platform was like one separate website, and was really hard to figure out where to find what information and define like a user flow, a user funnel. So I started this project with like naively. I was like, oh, I will just unify all the platforms into one website. And I did this for like 1.5 years. And at some point, people started to like it because it was very useful. And then we at the second time, we said, okay, maybe we should raise some fundings for that. And we started to think about this ReScript association thing. And then I got to know all the people like Cristiano, who has been very supportive of our work. And he's like, he liked the ideas and he introduced us to the team. And ever since, we started growing. And then in 2020, we really started like the new brand, and then said, okay, we have this core team, and now I'm part of this. I mean, I don't like this idea of having a core team, but I think it's important to have someone reliable for the technology you're using. And if nobody feels reliable, why should you use this? And that's why I'm excited that I'm on there.
Pretty cool stuff. Feross, any other questions or thoughts from you before we call it a show?
Oh, I'm gonna try and find a nice simple project to give this a try on.
Yeah, let me know how you like it.
Yeah, that makes me wonder, are there good example apps, or is there a version of like the to do MVC, or what's that? There's a real world open source app that has a lot of like front end implementations. Is there anything like that where folks can just poke around and look at not a complex ReScript thing, but maybe like a semi-complex one? Anything out there we can point folks to in the show notes?
Also, is there anyone who's using it for like specifically cryptography code? I'm just thinking the project that it might make the most sense for me to try it on is we have a little cryptography module that we just open sourced for Wormhole, and it's not that many lines of code. It's like probably wouldn't take too long to port it to a new language, and yeah, I wonder, that's the kind of code too that you really want correctness on, and it's worth extra cost for maybe making it a little bit harder for a random contributor to contribute, but like you get more correctness guarantees. And yeah, I'm just curious.
There that's a tough question I cannot answer, but maybe I can follow up later with that.
Okay.
Because I have some ideas in mind, but I'm still not sure if, because some things are already existing, but they're still in Reason syntax, and we don't want to particularly point people to Reason resources, which
Right.
doesn't make any sense, even though it's the same compilation platform. The best like real world example app is ReScriptLang.org. It's a Next.js app. You can check it out and
So
see
the playground as well.
Yeah, the playground is also written in ReScript. I'm not entirely proud of it, but it's pretty damn stable. So that's at least something.
That's something to be proud of. Yeah.
Yeah. And there are some open source apps. One is called Pupil First, but I'm still not sure if they're still on Reason syntax or if they already converted, because we have like this one command to convert your whole code base, and that's it.
Well, why don't
Yeah.
you do this? Hit us up with links afterwards, and we'll put them in the show notes if there are
Absolutely.
any ones that you would point to. That way you don't have to come up with them on the spot. And then, I mean, surely for us, the Tezos team is doing some aspect of that. I mean, I don't know what exactly they're using it for, but you know, they're cryptocurrency, but there also is cryptography involved.
Yeah, that's what I was thinking. I was like,
Yeah.
it sounds like a great use for it.
Yeah, totally. And I would definitely be interested in seeing the results of that conversion for us. So if you ever end up doing it, you know, I think it'd make a good blog post, or even just like, you know, tweeting out the links to like the before and the after of that module would be pretty cool.
Are there any automatic tools to like get you started with like most of the way to working? Like, can you port something that automatically port from JavaScript for you?
No, there's nothing like that. But you can. We have an explicit section in the docs about converting a JavaScript file over in a few steps, because we can drop in raw JavaScript in a type safe manner, or at least in a constrained manner. You should check that out. So you can take one expression or one function, drop it in as raw JavaScript.
Yeah, I did see that in your docs to embed raw JavaScript. You do %% raw, and then everything inside the parentheses there is just raw JavaScript. So for us, there's your path to an easy port. So you just wrap your entire module in that, and then you're done. You're in ReScript land.
Nice.
Yeah. Well, listeners, all the links to all the things, even some things maybe not brought up, which Patrick has hooked us up with, will be in your show notes. So check those out. Definitely keep up with Feross in case he does that port. I don't know what he just Feross on Twitter. Maybe you'll tweet about it. And check out rescript-lang.org as well. I should mention that this episode was requested by a listener of the show, a longtime changelog member and a friend of ours, Brett Cannon, who also happens to be on the Python core team. So you have his interest. So there's smart people who are interested in learning more about ReScript. Hopefully this episode gave some people a start on a path down that way at a very interesting language and toolkit and a view of making web apps. That's awesome. So Patrick, thanks for joining me. Feross, thanks for hanging out. We appreciate it. And that's JS Party for today. We'll talk to you next time. All right. We're now in the post show. No, that clap was like, 3, 2, 1. No, that was just me saying, all right, yeah.
Got it.
Cool.
Can I stop the recording now?
You can. Yep. Okay. And I'll throw a uploader link in the chat. You can just call it JS Party Patrick or something.
Episode number
175.
I don't know if that's helpful to put the number in. I always try to do that.
It is. Especially if we get backed up.
It's unacceptable that you're using Dropbox at this point.
Oh, dude. I'm sorry.
I'm just kidding. It's fine.
Does Wormhole have persistent, like something like this?
No. We don't have something like this yet. Yeah, I know.
Oh,
I know.
Come on, man. You can't tell it's unacceptable.
I'm just kidding. I know. This is actually something that I want to support, though. It would be really cool.
I would love that.
Yeah.
Because like persistent URL is what matters for us. Like just always the same place. Throw the files there, and then...
and then you get an email when someone adds the file, right?
Yeah, exactly.
Yeah. Do you pay for this, by the way?
We do pay for Dropbox, yeah, but this, I don't know if this feature is like a paid feature or if we just have to have a large enough Dropbox just for all of changelog, audio files and crap. So we do pay, but I don't know if
seems like a paid feature.
It seems like it is, but
Yeah.
They threw it in with whatever package we're on. I don't know.
Okay.
But yeah, that would be cool.
Yeah, I mean, it's a brand new tool, and you got a workflow that works. I'm just trolling you. I'm just kidding.
I'm excited to give Wormhole a try. I haven't had any use case because we just use this Dropbox for everything pretty much at this point. I was trying to think of like when would I actually send a file that's not
already
an audio
Dropbox
file in Dropbox, and it's just like it has us covered pretty much. But
here, I'll send you.
Send me a Wormhole.
I'll send you my audio over Wormhole right now.
Okay.
Okay, here.
I'll
put it into the Zoom chat.
Cool.
And it hasn't finished uploading yet, but I just pasted the link. So
that's my favorite feature.
Yeah.
It's just like I think that's a really compelling where you don't have to wait to upload it. Now I just loaded the file here, and I guess it's there now.
Should I name the file in a specific way?
You can just say JS Party 175 Patrick.
175.
Yeah, so that one was too fast for us because you uploaded already. But I was trying to say, what does it show me when it's not there yet?
Oh, it'll let you click on the file and begin downloading even before I finished uploading.
So like I'm chunking down the parts that are available, but
yeah, actually, well, it's even cleverer than that. It uses WebTorrent to send the files to you directly, peer to peer, while it's uploading it to the cloud too. So right now we're not doing the cleverest thing, which we're not doing yet, would be to notice when you've opened it in your browser, and then to pause the cloud upload and save all my bandwidth just for the peer-to-peer transfer to you. We're going to do that soon. But right now what it did was I was uploading it to the cloud, and as soon as you opened up the page, it made a peer-to-peer connection to your browser and started sending it directly to you. And then if you were to come to the page after it was fully uploaded, then it would use both peer-to-peer and the cloud to get it to you as fast as possible.
It would use peer-to-peer from you?
From my computer, yeah, using WebTorrent. So it's a direct like peer-to-peer connection between our browser tabs.
Until you close your tab, then I have to get it from the cloud, right?
Then you have to get it from the cloud. So I can't close my browser until I get the little check mark that says uploaded, now available for the next 24 hours.
So is the cloud plus you plus me are all just like the cloud is seeding it basically? It's a WebTorrent endpoint, or I don't know what the lingo is. Is the technology WebTorrent in all three directions, or is it just the peer-to-peer thing is WebTorrent?
So we're using WebTorrent is at the core of the whole thing, but when we actually go to fetch pieces from the cloud, we use HTTP web seeding, which is like this feature that torrents have, which is like you can say there's no peers, fall back to making requests from an HTTP server. So it's part of the torrent protocol, but it's just a little bit more efficient to do it that way than to use the torrent protocol, especially because like we're fetching it directly from Backblaze, which is the cloud provider that's actually hosting the files. And so their API obviously is just exposing HTTP. And rather than there's no point to routing that through like our own server just to expose a WebTorrent like interface. It's just like make your browser go get it directly from Backblaze. It'll be faster, less bandwidth for us to deal with, less things that can go wrong. So,
but in that case, that's if you drop the tab. When you have the tab open, you said I'm getting it peer-to-peer from you, but I'm also getting it from Backblaze HTTP, or?
Yeah, it's a hybrid. So it's like just trying to get it to you as fast as possible. So it'll prioritize like the connection that's fastest. Yeah, it's a little magical.
Yeah.
It's the goal is basically get the file to you as fast as possible. It doesn't matter how. Like you shouldn't have to think about it. It should just do the right thing, and that's why it starts letting you get it before I even finished uploading it. And I, as the uploader, can basically send you the link and then move on with my life. I don't have to be like, wait for this thing to like upload. And then now that it's uploaded, now I can get the link and send it to you. So I got to come back to the tab after like 3 minutes or 5 minutes.
Right.
And do this 2-step process. It's just like, nope, drop the file, get the link, paste, move on with my life.
Yeah.
Yeah.
The challenge there, the potential challenge there is, what if move on with my life is like me closing my browser because I've like mentally checked it off my list. Then you're like, oh, wait a second.
Well, it gives you
like close the laptop and move on. Right?
That is true. Yeah. So it gives you a warning if you try to close the tab. if it's not
like
done.
Don't leave this page kind of a thing.
Yeah. And then the other thing we're going to do, which will help with this problem, is there's a new Chrome. Well, it's not new. It's actually from 2018, but there's a Chrome only API right now that lets you do fetch requests in the background, even when the tab is closed.
Okay, there you go.
Crazy. So basically I can like start the upload process with a bunch of fetch requests. And then even if you X out the tab, it will continue to run those in the service worker until the upload is fully completed. So you can actually mentally actually close the tab and it will actually complete, awesome. Which is crazy. Yeah. And on Android, you can even kill the entire browser. Like if it gets killed for low memory reasons or the user swipes it up, it still uploads. It uses the OS, the Android system itself to do the upload. And the user sees a little like notification of the progress happening, even if the browser is killed. It's pretty crazy.
That's classic.
Yeah.
What happened with the animation? I can remember that you had like a super cool wormhole animation on, but I cannot see it render. Did you remove that?
The rotating background?
Is it rotating for you?
No, it's not.
Oh, well, maybe you have reduce motion turned on in your operating system settings.
Yeah, mine's rotating.
If you ask to reduce motion in your accessibility settings, then we will respect the setting and not do any motion.
Interesting.
So I don't know if that's what's happening.
Like this warping scene where it's like teleporting through. Or am I mistaken?
That's right. Yeah. It's just that we don't do it if you indicated that you don't like animation. So I think maybe that's what's happening, but if not, maybe there's a bug.
Maybe there's a browser in OS. Please submit your browser in OS.
Are you on Mac OS?
I'm on Mac OS and I tried it in Brave and I tried it in Safari.
Oh. So try going to your system preferences and go to accessibility and then go to system preferences, accessibility, and then go to the display section.
Oh yeah.
And see if it says reduce motion is checked.
Oh, it is checked. Interesting.
Yeah.
There's your real.
Oh yeah, now it's going.
Yep, it immediately starts. It immediately starts.
That's cool.
It detects the change.
That's so cool. I love that. It's like this little details.
It reminds me of the old time machine. I don't know if they still do it, but Mac OS used to do the time machine, the warping, and you go back in time. It was cool. It was kind of corny UI. I liked it. It's like, I'm going to try one.
Still do that?
I don't know. I haven't used it for a long time.
Here, let me do it. Let me do it in time machine. Oh, it's so plain. It just shows you your desktop wallpaper. What the heck?
Yeah. See, probably when they were like going away from skeuomorphism, they probably pulled that out.
Oh, but I think it was kind of so charming. Yeah, because you don't do time machine that often, so why not just when you do it, make it fun? I don't know.
Magical, exactly.
Oh.
Well, it's pretty cool for us. Definitely just pick a Thursday, man, and we'll do a wormhole episode. And just because there's so much cool tech that you use on these things that's just like worth talking about, I think, on the show.
Cool. Yeah, for sure. I'll pick a Thursday. That sounds good.
Awesome. Patrick, did you get my uploader link there? I put it in the Zoom chat. It's just a Dropbox uploader. Throw your file there. We're on a 1-week turnaround, so we ship on Fridays. So this episode will go out a week from tomorrow.
Oh, I already uploaded it, I think.
Oh, sweet.
It should be up.
I didn't check.
Jerod, I also threw mine onto Dropbox too.
Oh, I did download it, so I'll have 2 files.
Okay. Cool.
Just let me know if you didn't receive
on
it.
Make sure you're not hacking with me. What?
Just let me know if you didn't get it.
Let me take a look here. Magic of Dropbox is it should already be there. Yep, I see Patrick's and I see Feross's. Awesome. Yeah. Thanks for coming on the show, Patrick. We have you in our system, so when the show goes live, you'll get an email from our robots with all of the sharing information, etc. We also send a free t-shirt to every guest, so you'll get a coupon code on our Shopify. You can hop over there and send yourself a free t-shirt as a thank you for your time. That's it, man. We appreciate you coming on.